Hello and welcome back. Today we're covering a very important topic, bugs. So buggy code can cause a lot of headaches, but just know it's all part of programming. There's actually a saying that goes 90% of coding is debugging, and the other 10% is writing bugs. So while clearly a joke, know that you're going to write bugs sometimes, and even the most advanced programmers write buggy code now and then. It's just part of what we do. In this video, we're going to be talking about what a bug actually is, the different types of bugs you'll come across, and a variety of methods to find and eliminate them. So let's go ahead and roll the intro and get going. Alright, so debugging is a process for fixing bugs or problems that find their way into our program. So a good analogy I've heard recently is that debugging can be similar to a hidden object game. You're looking for something small, something that isn't quite right in a relatively big program. It takes some patience and some focus. Of course, the number one way to not have bugs in your program is to simply not write buggy code, right? Again, it's going to happen at some point whether you take all the precautions or not, so make sure not to feel discouraged when it does. It's absolutely normal. We can take steps to avoid writing buggy code, or at least help us find those bugs later on. Things such as using good comments in our code, using descriptive and meaningful names for our variables and functions, using functions themselves, and making sure to use proper indentation and white space so your code is more readable overall. So there are three types of errors you could come across. Syntax errors. Syntax are the rules for how to write code. Each programming language has unique syntax, and Lua is no exception. If you've made an error in the syntax of your code, the program won't run properly right from the start, and you'll typically be given an error. The editor in Roblox Studio will typically let you know even before running the game that you've made a syntax error by underlining the problem area in either yellow for a warning or red for a full-on error. Note that warnings don't prevent a program or script from running, but errors do. When you run the game with a syntax error, you should get an error in the output window as well. The second type of error you'll come across is a runtime error. These will typically allow the program to start running, but then crash at some point down the line. A good example of this may be when a user's input calls a function in the program and the error is actually occurring within that function. So the game runs fine until the player presses that input button and the problematic function fires off. Similar to syntax errors, when a runtime error occurs, you should typically get an error message in the output window. The last type of error you may get is a logic error. These are usually the tough ones, since they tend to not warn you before they run the program that something may go wrong, and then they may not even tell you in the output window when things go wrong. That's because a logic error is the code running correctly as written, but it's not doing what you intended it to do. So remember this, computers are never wrong. It's the instructions that you gave them that are misbehaving. Let's dive deeper into each error. We'll start with syntax errors. A syntax error is a mistake in how the code is written. Computers only understand commands if they're written with specific rules. If the syntax is not exactly correct, the code won't run. Let's make a new part in our workspace. I'll actually go ahead and add it to our parts folder that we have here. We'll do part. And we'll use this as an example in a new script to show some of the ways that a syntax error can happen. I'll go ahead and add a new script into here. I'm going to go ahead and rename this script errors just for clarity. And we'll get rid of our print hello world. Alright, so one of the properties that we can change of a part, as you can see here, is the material. And we can do this by referencing our part. So we'll go and do workspace dot parts folder dot part. And now we can access the properties of that part. So we'll go ahead and select the material property. And now we can assign a property value to our material, and we'll use rock as an example. And you can of course see this. You can click on these and you get a little table here, and you'll see that rock is one of the options. So if we run the program, you'll see that our part has changed from plastic to this rocky color. We'll go move it off here so you can see a little bit better. There it goes. So this is the correct syntax for doing this. If we instead use a lowercase m for our material, one of many common mistakes that could occur, by the way, we'll get an error now when we run this, stating that material with a lowercase m is not a valid member, meaning a recognized property in this case, of our part. So let's go ahead and stop. Let's fix that. Go ahead and go back to a capital M. And now let's go ahead and remove our double quotes here and run. This is also another syntax error, common one that you might come across. And this error says we're unable to assign this value to our material property because it's not formatted correctly as either an enum item, we'll go more over that at some point in the future, a number, or a string, which is what we had before with the double quotes. That's what it's expecting, and it did not get one of those things. So that's why we have our double quotes there in order to get that to work. So these are only a couple of simple examples of syntax errors. There's a ton more you could come across. And you'll notice, like, when I had that, it didn't really give me an error per se. It does give me a warning, however, as it's saying, in this case, unknown global rock, meaning it doesn't know what this variable is because it's treating it as a variable. However, if we make this the lowercase m, like we did before, there's no errors going on there at all. So know that syntax errors don't always tell you before you've run the program that it's going to be a problem. So in that case, you'll have to rely on the output window. All right, to quickly demonstrate a runtime error, I'm going to go ahead and paste this code in. And it's essentially doing the same thing, but now we're using a function containing a syntax error. So you can see we're using a lowercase m here for the material again. I'm utilizing a wait function in the task library. Roblox is providing this for us. We'll eventually cover this in the series further down the road, but this allows me to halt the program from executing any code for a specified number of seconds. Here, I'm waiting 5 seconds after we print a message to the console. We're basically just printing what the current material is. Should be plastic. And I added this to show that the program, our script, is running when the game starts. But after 5 seconds, it's going to call the function. We're feeding in rock as our material that we're trying to change the parts material to. And that's when it's going to crash because, of course, we have our syntax error there. And then I've also got it printing what the material should be after it's changed to show that this is not going to run after that error occurs. So if I run this, parts currently plastic, 5 seconds later, our function gets called, and now we have material with the lowercase m is not a valid member, not a valid property there. And notice that it has not changed to rock, and we do not get our additional print statement saying what the material is. Of course, if we come in and change this back to a capital M so it's proper, we run, parts material is plastic. 5 seconds later, it's going to change it to rock. We don't get an error, and the parts material is now rock. So finally, let's cover the logic error. So these can be harder to spot. I'm going to go ahead and paste some more code in here. This code, as is, will run with no errors, but it may not run as intended. So we have 2 players' scores and variables at the top, and we want to print their combined scores to the console. But when we run the program, the total score printed is 18. We should have gotten 9 plus 5, which is 14. So what's going on? Where's the error? Well, it looks like we've got player 1's score being added to itself for the total score rather than adding player 1's score to player 2's score. So obviously we can just change that. And now when we run this, we get our proper 14. So again, there were no errors there that you could see. It just gave us a different result than what we intended. So then we had to actually look for and try to spot where that logic error occurred. So again, this is a simple example, and in a real program, especially one of significant size and complexity, this can be much, much more difficult to spot. Obviously with this, we had 4 lines of code to look through. If you've got, 100 or even 200 lines of code that you have to look through, that's where we want to go through some of these debugging methods. So here's some common methods to debug your code. Comments. Not only can you use comments to help describe or label sections of code for added readability and ease of finding the problem area when an area occurs, you can also comment out entire sections of your code to prevent them from being run. So this can simplify the program, only running through bit by bit of your program and narrowing down the problem area when running into logic errors, which is especially useful. In Studio, you can actually highlight the code you want to comment out. For example, we'll do this. And you can either use this button up here to toggle comment, and that will comment an entire section. So let's do both these lines here, and you can see it comments both those lines out. Or you can hold down Control and use / on your keyboard as a shortcut, and that will also comment those out all together. Nice part is you can also use the same thing to uncomment them and toggle, obviously. So the output window is the most common place to find when an error occurs. Let's go ahead and go back to this program where we were incorrectly changing the material here using this function. So if we go ahead and run this, not only is it going to print out error messages when running into syntax or runtime errors, you can actually click on these messages to be taken directly to the line that's causing a problem. So of course, you can also just look at the message, and depending on your enabled settings, I went over these before using these 3 dots. Depending on what you have here, we can see that this is coming from the errors script. So meaningful and useful names for your scripts come in handy here. And it even tells me what line that's on, which is line 4. It's the same thing that it says here, script in our server script service.errors on line 4. In our function, specifically change material, is where this error is being thrown. You see another line here where it says line 11, and what that is, that's where the function's actually being called. So it's kind of an interesting little breadcrumb situation that leaves you there, where it says the error is typically coming from here because this is where it's initially being run from, but the actual direct area of the message that you want to pay attention to is where the actual error is being thrown from, and that's why it's kind of nice to have this listed out here for us. You'll also notice even on our original print statement, it shows you what line that's coming from in our output window as well, which could also be helpful. Go ahead and stop that. Go back into here. So another common use of the output window when debugging is using debug print statements, which you can use and add near lines of your code that you're unclear about, or to print contents of a variable that you might be having issues with. So let me go ahead and copy this code into here. It's a little bit of a peek into what we might be doing in the future at some point. So here, this debug print statement is going to print out to the console when the function runs, and this way we know that the function is running correctly. So if we go ahead and play the game, we have parts not a valid member because I forgot to put that into our part folder or our reference there. So immediately got that. We have touched the button already, which is not the case. That shouldn't have been the case. Right, it's because it's on the ground. Let me go ahead and make sure that this is anchored. So we'll come down here. I'm just going to search to make it easier for myself. Give it the anchored property, and then we'll lift it off the ground. Now when we play, it doesn't tell us it's been touched yet. And when we touch it, now it says we touched it. All right. So if you are using these debug print statements, please be sure to remove them when they're no longer needed. They add needless complexity to your code, making it less readable. Plus, they can really make a mess of your output logs. Another one that we can use is the script analysis window. So this is a cool feature in Roblox Studio. If we go to our View tab here, there's an option called Script Analysis. This will open a new window for us, a new little panel we can move around wherever we want. I'll go ahead and leave it down here for us. So if we make any errors, such as using a lowercase m, for example, like I said, that's not going to pick anything up because it doesn't know that is not a property of that, mostly because we didn't tell this exactly what it is. But if we do one where we get a warning or an error, like when we removed our parentheses here, you'll see that we have this yellow underline, and it's showing us down here, this is an unknown global. It doesn't know what plastic is, right? It's thinking of this as an actual variable. If we put one quote around this, this becomes an error. Again, we can hover over this and see it's a malformed string, right? We didn't finish it. It even says that there. And again, we can see that error down here. This is all in real time. We're not having to run our program to actually see these errors. So as you're learning, this is kind of a nice feature to have opened up as you're typing your code to see if you are making any mistakes before you even have to run the code and find it. It is also notable here that you can see this is line 5 for the first number, right? This -20 is actually the column that this is in, and the columns, you could think of those as each character, right? 1, 2, 3, 4, 5. So if we're over here, basically this is character 20, right? So there's 19 characters back here. That's a little less useful, unfortunately, but it is something that if you actually count out where they're at, you can kind of see where the error is very, very specifically on that line, so that's pretty nice. Last, but certainly not least, is the powerful breakpoints. So breakpoints in Roblox Studio are really, really cool. I'm going to go ahead and delete this errors. I'm going to re-enable our treasure chest script. Let me get rid of this search here so I can enable it. And what this was doing, basically, we were just adding a number of coins to a player's coins value for every time we open a treasure chest. So I'm going to add a breakpoint to line 4. To do that, you hover next to the numbers, just on the right side of the numbers. You'll see these little transparent red circles showing up here. If I click on line 4, it becomes solid red, and that is now inserted a breakpoint here. So what this will do, if I go ahead, we'll just run since there's nothing that needs to be played here. If I go ahead and run the program, it stops, and you'll actually see rendering is paused for debugging. So essentially the game has stopped running. It is still in the middle of doing whatever it might be doing, but it stopped running because we've reached our breakpoint. And what this actually is at this point is the program has come down, the computer said, okay, we've got a variable for coins. Oh, we have a function definition, so let's go through that function definition, and it reached this line as it's reading that function definition. What we can do is using these 3 options up here in our debugger section, so we can step into, basically just means go step by step, or if you are in a function call, it will step into that function and go through what it's doing step by step. We can step over, meaning that in our case, we're inside of this function. We can step over whatever this line's going to do and go to the next line, or we can step out, so we'd step out of our function. In this case, since we're just doing the definition, we're going to step out of that. And now you can see that it has come down and we are running this one. I guess we stepped out instead of the other one. So the first one ran, you can see you found a treasure chest, current amount of coins is 125 because we had 100. And we added 25. We are currently on this function. So open treasure chest 50. So if we step into this, we're actually going to see our yellow arrow point up to this line now. So we're now inside of our function and we're going line by line. So we're saying coin plus equal amount. So we're assigning the new amount of 50, adding it to our coin. So if we step into, that has now been completed. We're now on the line to print, you found a treasure chest. So when I hit step into, we should see that it's going to run that line and you found a treasure chest, done. We're now on the next line, we're gonna print current amount of coins and concatenate that with the number of coins that we have. So again, we step into that and it's going to print that. That is done. We've reached the end of our function. If I step into again, now it comes down to our open treasure chest. And we can step in again and go through this again, and you'll see that it continues to do things as needed, and step into, and now we're at the end. So if we do that, now our program is running again, but there's nothing happening because the script is done. So let me show you another thing with this as well. Similar to how we have this script analysis window, which I'm going to close for now, we can go to view, and this is really useful. There's an option for watch. If we open this up, we have this new window opened up. And what this is going to do is keep track of variables as we're going through our breakpoints. There are scopes that we can access, local, up values, or globals. Local is what we're looking for. Obviously, we're using local. So in our case, we do have this variable coins. So if we go ahead and run our program and we hit this breakpoint, close this, you'll see that we immediately have coins as our variable, one of our variables that we're watching here. This is an up value, as it says, and it currently has a value of 100. It even tells you the data type. In this case, it's a number, but it's a double in this case. So when we step into this now, because we have an amount as well, and this amount that was passed in was 25. So you can see that's at 25 there. So we step into that, that's done. Now our coins value is 125. And then we do our print statements. And then we go to the next one, and we can see that we have an open treasure chest, which is a function. Our coins value is still being kept track of as 125. We step into it again, and now we can see that our amount value is 50. Our coins value, again, still 125. So when we add those together, now our coins value is 175. So you can use this as a really great way to keep track of variables and make sure that they're doing the proper thing. So if you're coming across a logic error, a lot of times it could be that maybe you've used a bit of abstraction using your functions and you're not quite sure where the issue's coming from. So you can use this and keep an eye on everything that's happening step by step in your program and actually get that going. So I will also mention you can right-click your breakpoints and edit them, and you can get a lot more going on. That is a little more complex than I wanted to go over in this video, but that's it. There we have it. So we know what bugs are, we know the types of bugs we commonly see, we have a bunch of options for finding and eliminating them. The option you choose to use will ultimately depend on personal preference, often coming down to either what's the easiest and or fastest option, or the option that best gives you the amount of information that you need to crack the case, so to speak. Again, like using the watch window there. So make sure to subscribe if you haven't already. If you'd be so kind as to hit the thumbs up if you liked the video, leave a comment to appease the YouTube algorithm, and ring that notify bell to be notified when the next video goes live on the channel. A short aside here, I had a question from a previous video about more advanced scripting in Roblox. I would love to actually get back into the advanced stuff. I wanted to make this series of beginner-friendly content to be able to reference my own content for those that may need it as I'm going over more advanced topics in the future. But I've tossed around the idea of doing some live streams here and there that I could take questions and requests directly from you in real time, almost like a live version of the Roblox dev forum. So let me know if you'd be interested in that by leaving a comment below. And if I get enough interest built up, I'll go ahead and put a poll out to try to see when the best times for streaming for all of you would be, and we'll take it from there. All right, that'll do it for me today. I'll see you next time.